at Playtech Sports, who are building betting web clients for a bunch of different operators, Ladbrokes, Cecil, etc. And let's have a look at how we build them. We have our betting web client, and we have a betting API. So we want to have this data here to our web client. So we need some stuff in between. We have a content server aggregating the data to create a data model for our web client. Our backends we run on Spring Boot to have a small executable with an embedded Tomcat, for instance. We're using Spring a lot to avoid having to write boilerplate code and just focus on the business value. So this is the content server, and this one pushes data over a message bus. And the message bus is built on Redis, and this one forwards data to front-end servers. So we have a lot of front-end servers serving the data to betting web clients. So that's mostly the stack. We also have a back office where operators can go in and customize what data to show to the clients. All right, so let's use some parts of this stack for what we want to show today, remote controlling a web client. Remote control, but we will do a simple to-do app in the client. We will have a front-end server, but only use the WebSocket technology, nothing else. So we call it the Websocket Server. We will change the content server to build something on Node, and this server will only serve a remote control app where we can control our to-do app. And the betting API we don't need, of course. As an extra twist to this, we also want to send data the other direction. So data, there are send commands. We're sending commands from remote control app all the way through the to-do app, and then the to-do app will respond with data back to the remote control app. That's the idea here. So let's look at the to-do app.
So we will go through these 5 boxes and how we a few implementation details on all of them. We have the goal here is to build a small application on React, which will have a list of items, of to-do items. You will be able to add new items by entering the input box and press the add item. You will have the items tappable, so you can tap them to check and uncheck the box, and you have a remove icon to remove the items. And this is a normal to-do app. We will build it, bundle it with Webpack. We will use Babel to be able to write ES6 code, React to render the front end, and Sock.js and Stomp to communicate over the WebSocket. Let's have a quick look through the application, a simple HTML, where we basically have a root container where we will render the React application. And Webpack has created one bundle.js with all our JavaScript code in. We need a data model for the to-do list. This will be a simple JavaScript array and we hard code in 3 items to begin with. They have 3 properties. They could be checked or not. There is a text and an index to identify the item. This model will expose a number of functions to mutate the list. We can retrieve the list and delete an item and toggle an item, add an item. And then we have a onChange. So the idea here is that we have one model that will that you can subscribe to changes by calling onChange and passing in a callback. And we will basically call this callback with a list whenever anything has changed. a main file. This is the entry point for Webpack. We point Webpack to this file, and it is importing the model. We need that. The first thing it does is render the to-do list, and it registered the render function on the model. And the render function is easy. We will render the app component, and one prop only, the list, and we point to the root element. There is where the app component will be rendered. We have a small number of components. We have the application, which is the wrapper around it. We have, we see basically 4 different things in this. We have the header up here, the to-do list, another component we will see, add item, which is the input form, and the footer. And we have the list. And this is a very small, we just iterate over the list items, and we generate list over the list and generate list items. And so for each item, we use the list item component. And 3 parts, the checkbox, the link you saw, and the delete icon. And we import the toggle checkbox and delete item from model, and directly we call toggle checkbox. If we click the link, we call delete item if we click the delete icon. This will in turn mutate the list in the model, and the subscriber to the on change in the model will be called. And the last one is the add item, a small input box, and a button. And here is a simple concept in React that we bind the state, the text state, to the value of the input box, and we use that later on when we are clicking the add item, resetting the text when we have clicked. So what we will do, we will build this one, and we will need to host the application. So we have a very small node server, an express server to do this. So let's see, we have the client. We have a public folder with the index.html and some fonts and CSS, and we have the components you saw, the main file and model file. We run Webpack, so we get the bundle.js and the source mapping to that one. The typo. So the server, it's a very small one. We have one app.js, and basically the only purpose of this one is to host the bundle file, which will be inside the build folder, and the public folder, which has the index.html. And we expose it on port 4000. All right, so let's start that. Node app. Listening to port 4000 and browse to that one. There we go. A simple to-do app. You can click the items and you can add stuff to it. And you can remove. There we go. So far, a simple application, no remote controlling whatsoever, but that we will start to take care of.
All right, so first part, more or less done. But right now, like Alvo said, it's just a simple web application. Let's have a look at the Websocket Server. We will build this using Spring Boot. So there are 2 responsibilities for this one. Send commands to the to-do app using a WebSocket, and communicate with Redis, both send messages over Redis and subscribe to commands from the remote control app. Okay. So we go to start.spring.io, where you can use a Spring initializer to set up a Spring Boot project. We will use Gradle to build it. group Playtech, and we will call it the Websocket Server. We need some dependencies here, so we need WebSocket support, and we need redis. Okay, let's generate that. We will get a zip file, and if we click on that one, it will be extracted, and we will find a build.gradle, which we can open in our IDE. So here we have the WebSocket server. Let's have a look at build.gradle, and we see 2 dependencies added, Spring Redis and Spring WebSocket, and Spring Boot, of course. There is one Java class generated for us, the entry point with a main class, and we will add WebSocket support here. So there's an annotation, enable WebSocket message broker. And we also want to do some configuration, and that's done by extending the configurer. These are all parts of Spring. We want to register a HTTP request URL which should be invoked by the to-do app to set up the WebSocket. So that's the URL here, the to-do WebSocket. Then we should also register an internal endpoint within the WebSocket where we can send messages over the protocol inside WebSockets. And that's /register. Okay, some commenting here. So this is the configuration for setting up WebSockets. And now we are ready to create a controller for this, much like if you can create a REST controller. So we annotate it with @controller, another Spring annotation. And then we add our endpoints so we can bind logic to those endpoints. First, we will add some dependencies. We need Redis client, of course, to communicate with Redis. And we also need a messaging client to communicate over the messaging protocol inside the WebSocket. So 2 dependencies here. Then we add a subscribe mapping for a destination where the to-do app can subscribe. We will get the WebSocket session ID generated by the WebSocket server. And now we can publish over Redis that this session ID wants to register. So this will be registered on the remote control server in the end. We will show that later on. When we have published that, we will start a subscription for commands from the remote control app. And that's done on the from server channel on Redis. And we added a Lambda there as well, and this is what will be invoked when we get something on Redis, on the subscribe. And the data received will just be forwarded to the to-do app client. So that's messaging.send to client /register. So that's the one that will be used in the to-do app client later on. There's one more mapping here, the message mapping. So that's where the to-do app will send response data whenever it will get the request from the remote control app. So that response data is sent over Redis with from client. So this is actually the WebSocket server. And now we can start it. All right, up and running. We can see that Spring has mapped user register and /respond. And we have the server running on port 8090. So we're done with the WebSocket server. We need the message bus, of course, and this is out-of-the-box technology, not something we have created. If you recognize the icon, this is Redis. So you could install Redis on your computer if you want to, or you can just use Docker and don't care about how to install it. So what we do is we do Docker run Redis, and then we specify also a port which we want to expose where we can access Redis on the machine on localhost. So that's all you have to do to get the message bus up and running. And this is fetched from the official Docker Hub, this image, if you don't have it already. That's the message bus. And the final server part here is the remote control server. This one has two responsibilities as well: communicate over Redis and expose a REST API to the remote control app. Let's have a look at it. Two different parts. So if you recognize this channel, maybe it was used in the Websocket server to send data from the to-do app to the remote control server. So we will subscribe to this channel with a wildcard, and anything received will be handled by this method here. And three things can happen. A client can connect, then we add it to our client collection in remote control server. We can do disconnect. Otherwise, it's just data that should be sent directly to the remote control app. So we will just forward it to the remote control app. So that's Redis handling. And we have the REST API, of course. So we have set up some routes here. The first one is just to get all the clients in the remote control app. List all clients connected. That is all to-do lists currently running. And then we have some operations on the to-do lists. We can get the list for a session, toggle an item, delete an item, add an item. And finally, we can do ping. This request here will return instantly to the remote control app. All the others here will result in a command being sent to the to-do app, and then a response will be coming back. We are ready for the remote control app.
Right. So this is the interface where you're supposed to be able to control all your clients that you have. In our setup here, we will have 2 or 3, 4 clients maybe, but if you have something in production and have tens of thousands of clients, this should be the place where you find your client and do something with them. Let's have another look here first. What we'll do here, once again, is that it is going to be a React application. It's going to use the REST interface from the remote control server. And that operation, that will hang. We won't get a response until we have pushed over Redis, sent it through the WebSocket to the to-do app. We have gotten back an answer from the to-do app over the message bus to the remote control server, and then the HTTP request will be resolved, and the remote control will get the answer. So this is what it's going to look like. We have all the clients listed with the session IDs that the WebSocket server created for us, and a little ping button. And if we click on an item, we can connect to that client, and we will see that client's to-do list. So what happened here is that we sent the get list to the remote control server, and the remote control application the to-do application will respond with a list, and we will render it here.
So can I ask you?
Sure.
The to-do app won't send anything until it's requested to do.
Exactly. So the only time when the application takes an initiative is when it's connecting to the WebSocket server. Then the WebSocket server will create a session ID for that one and send it so that the remote control server is aware. Then in the end, it's the opposite direction of what you're used to in web application. It's the server that is sending a request and the application that is responding. So, and how it's set up here, you send a command. For example, you can click toggle. We will send the toggle command, and then following that command, we will directly do a get list again. So we will get the new list back. So we won't keep the state in this application. We will always retrieve the state after every operation. And the technology, how we wrote this, is more or less the same as when we did the to-do app, so we won't go through too much of this. We have 3 components. We have the application that is setting up 2 routes. one to show the list and another one to show the details. And then we have some logic. We will have a short look at the client model. And basically what we're doing here is that we're exporting a number of operations that you can do. You can get the list, you can toggle an item and delete an item. And all of them will return a promise that will be resolved when we have gotten a response back over the HTTP request. And we're using the built-in fetch that's available in almost everything except Safari. So we have a polyfill for that. Yeah. But yeah, you send it, you get a response back, and you resolve the promise. And we do the same thing for the toggle item and delete item and add item. So now to the interesting part in the to-do app is to hook this up with a remote control server somehow. We will visually add a little icon here in the top right corner to show a thumbs up if we are connected or a thumbs down if we failed to connect. So let's see here. We go into the source folder. We had the components we saw before with the main file and the model file. We need to add a new module we call it remote control client.js. We need to mutate and get the list from the model, so we import that one. And we will set up a Stomp client. And the only thing that we will export from this module is the connect function. So that's something we will do from the main file later on. And that one is setting up the sock.js. The sock.js is setting up a WebSocket if it's possible. There could be something in the firewalls prohibiting us from that, and then it would fall back to long polling on HTTP. And then we configure the Stomp client to use the socket, and we connect. When we got a callback, we will be connected. We don't handle any error cases in this project. It will always work. So we set connected on the model, and then we subscribe to the endpoint that you saw earlier, user/register. And sending the callback there, and this callback will be called every time we are sending a command to the client. So we're getting some data in, and we parse the body of that one. And we set up a response object, the thing that we will send back eventually. There are some, we will need to set the same message ID as we got, and the status OK. And then we are going to switch over the different commands that we can receive. So we have start with a list, yeah. For the list case, we augment the response object a little bit. We add a list property and receive the list from the model. And then we have we have the toggle, which we will call toggle checkbox with the data.value, and value here would be the index of the item. And then similarly with delete, we call delete on the model and pass in the index. And finally the add one, which will add an item. In this case, the value will be the string that we would like to add. And a default case, throw an exception if we get an unknown command. And then it's just to stringify the response object, so we can send it over Stomp and call send on the Stomp client. The options, the second parameter is empty, no special options. We send it to the response endpoint. And then we export the connect. So we have all the commands for dealing with the list. We can get the list, toggle an item, delete an item, and add an item. We just need to add the ping one as well. We call a function called flash background. I will not show it. It will flash the background, so we can identify what client that we are working towards. All right. So main.js, the small file, we need to import the connect from the module we wrote. And after we have rendered and registered for changes on the model, we call connect. And a small difference here, we need to pass in the isConnected as well. So we add another prop to the application. The app component is connected. We pass in false in the beginning. So that should do it for the main file. And now we have the, let's see if the model file. Yeah, this, before we only cared about the list here in the model. Now we hold the state of the connection state as well. Set that to false and add a function set connected. So yeah, we stop by calling notify, and notify is a function we call after we have done anything on the list before, after we deleted an item or toggled an item. What it does is it checks if we have a subscriber. If we do, we call that with the list, and now also the isConnected. Great. So the last thing we need to fix is the component, the application. We passed in isConnected, so we will need to add this icon in the top, the thumbs up or thumbs down. We're using the common bootstrap CSS, so all these navbar right are bootstrap classes. And we call a little helper function, render connected symbol, and that helper function will check the isConnected prop, and if it's true, we will return a span with a thumbs up class set. So once again, some bootstrap classes here. There we go, thumbs up. And no surprise, a thumbs down if we are not connected. So this should be all. So it's the only thing left to do is to build the application and to see if it works. So run Webpack. And we go to the server and run node. Run the node server. And we have a thumbs down still. So that's the common way, right? You get an error. But to set connected is not a function of the model. So we did something wrong in the model. It was good because I got to show the thumbs down also. So we implemented the set connected, but we forgot to export it. There we go. We try again. We build and we run it. Yay! We have a thumbs up. So your turn to wrap this up and show the all pieces together.
Yeah, so once more, let's show it all together. So we have 5 boxes here for our different services. Let's start with the To-Do app that's hosted by a Express node server. So it's up on 4,000. Let's start it. You've seen it a few times now. There it is with a thumbs down. Yep. And we need our messaging bus. So again, we will start this one using Docker. Here we go, up and running. And now we can start our Websocket server, so the To-Do app can communicate with that one. And this is the Spring Boot app using Gradle for building. So we just run Gradle boot run. It will compile and build and run. And you've seen this log before, up on 8090. Okay, thumbs up. Nice. And we need a remote control server, so let's start it in that small box. And this one is a node server, as I said. So just run it, and it will be hosted on port 8100. And we need the remote control app, which is hosted on a separate Express node server. Port 5000. So now everything is up. Let's open the remote controller. And the remote control server doesn't maintain a state between sessions, so you had to reload the to-do app client to get the states. Okay, we can ping them, we can flash the background there, and we can delete items. We can send some to-dos that we think that they should fix. And we have the other clients. Let's remove all of these and ask them to join the Christmas party. Okay, that's all the services. So, what have we achieved here? We have shown a concept of how multiple web clients can be remotely controlled. This is of course a small example for to-do app, but there are some real-world examples as we see it. For instance, sample memory usage on web clients in production, enable error debug logging and sending those logs to server for specific web clients, inspect internal state, and that's what we did here. We inspected the to-do list for a web client, broadcast message to all the clients, a call center with a chat, of course, is it's a good way to use this. And you can also use it for automated tests. There are frameworks like Selenium and so on, but this is quite a different take on it. But this could be used for remote controlling your clients when you do tests. What we've also done is demonstrate some of the modern technologies that we are using at Playtech Sports to deliver our high-performing betting applications. So, like you've seen WebSockets and Redis, React, Spring Boot, Node, and Docker, and we're using all of this in Playtech Sports. Yes. I think we have some time left, so if you want to have a look at the code, it's there. It's a public repository at github.com/Mobenga, our organization. Some instructions here. You build it all with this one here. This will build all the services and also create Docker images, so you need Docker. And then you can use the Docker Compose concept to get it up and running. Let's talk a little bit about Docker Compose, just a few seconds. So this is a Docker Compose. This is where you can configure all your services in one place. It's a nice way to get services up and running. So we have our 4 services here we have built, and also a third-party service. So they're all connected together here in one network, and we can configure which ports to expose to the host machine, the local host, and then you can run this with one command. Should we show it?
Yeah.
Yeah. All right. So this is the Git repository, and we have a Docker Compose file here. So all you have to do is Docker Compose up D. D is to daemonize it, so we can still use the terminal. And there we see I actually already had started them, but this is how we start it. All right. And then we can do Docker Compose PS, for instance, to list all the services and how they're started internally and what ports are exposed. So let's see. So there's the to-do app. And there's the remote controller app. You can actually, if you're connected to the Wi-Fi here, you can connect now. Okay.
There is public Wi-Fi if you want to try. I think it's not possible.
Someone should connect to it. And you can connect to the remote control app as well and control our to-do list. Oh, sorry. Yeah.
Great.
Anyone connecting?
I couldn't connect. The Wi-Fi.
Ah, it is.
Ah, there's one. I can ping you. Who's that?
Oh,
So add a to-do item.
yeah. I had one of those.
Three. Measurement for this. Okay. Please work. Hello. Okay. Thanks. I think that was the last slide.
Yeah.
Thank you.
Very much.